Welcome to the Data Friday. My name is Michael Olschimke. I'm the CEO of Scalefree, and we have this session here essentially to allow you, the audience, to ask questions about Data Vault, data-driven applications, MVP work, and so on, right? MVP applications, cloud computing, and so on, data mining. And yeah, all the questions are allowed. You can use the chat here in the client to raise a live question. You can use the Q&A function in the client. Just raise your hand virtually, because I don't see it physically, right? If you raise your hand before your webcam. And you can also use a form, which I'll show you the link for after today's session to submit your questions, essentially. And yeah, if you receive multiple questions, I would essentially cherry pick those depending on my mood, or essentially typically on a larger strategy, essentially, or some series. And it's time boxed, roughly 10 minutes. That's a good question, essentially. And if there would be no questions at all, I will talk about my side project here, my hobby project, but didn't make any progress. So it's good that you're asking a lot of questions, actually. So I'm not sure if we get there this year, essentially. So we'll see. All right, so let me just share today's question. So this one is really about hash keys and HashDiffs. And there you go. And yeah, so what's the recommended way for hashing, essentially, and a couple of options here. So the first one is here regarding the hubs and the links, the hash key and hubs and links. And there might be some, I believe, optional hub references involved. So when a link has refers to hubs, and some of them might be null. That's what I assume here. Should we replace the null value with the default value before hashing? So yeah, so when we calculate the input for the hash computation, I mean, everything in the brackets here, we have to replace null values by empty strings, because in many installations, null values would lead, we're using here some concatenation function, right? String concatenation. And many implementations in a string concatenation would return a null value if one of the inputs is null. That's number one. And then you also need to make sure that you have a delimiter in between the fields. There must be a delimiter, because of when you replace a null value by the empty string, it could lead to duplicates actually in your hash computation, leading to hash key collisions, even though they're not collisions from a mathematical standpoint. They're collisions from the input, essentially. So always make sure you have a delimiter in between the business keys. And in my opinion, we also typically quote those business keys and add, besides the delimiter, we add an escape character. So if one of these three characters, let's say you're using a comma as a delimiter between the columns, using the quote character and the escape character, if one of these three characters is inside your incoming data set in one of the business keys, you would have to escape those characters and think about your business keys, to be honest, because I'm not sure if a backslash or a comma makes a good business key, in my opinion, but it's another story. But it could be there, so that's where we replace them, and that's essentially the input for any hash computation, hash keys, hash diffs on hubs, links, satellites. That's number one. So we replace these null values. And yeah, we got the reason already. So it's really about making sure that the outcome of the hash function is not null, and dealing with collisions, potential collisions because of the inputs. So let's see first quick answer here. Let me just double check the chat. Okay. So, and then for the HashDiff value, and yeah, so sorry. And for hubs and links, it's more or less the same approach. The hash key is always computed like this. Even if you have composite business keys on a hub, you always take the business keys, concatenate them with comma in between, escape that, quote everything, and that's the input for both hubs and links for the hash key. Now for hash diffs, you show here the code based on attributes. So you do essentially the same. Again, do the same, which means add the comma delimiter, the column delimiter, which might be a comma or something else, doesn't matter. And always quote the inputs and escape everything, because here in your data, I bet there is a chance, relatively high actually, that one of these characters that you select, the comma, the escape, the quote maybe, that those characters might be inside your data, in your descriptive data, right? There's a high chance for that actually. So yeah, so always treat those inputs. And then the question is, and that's the interesting one here, in my opinion, or for the more interesting one here on the slide, should we include the business key of the parent of the hub or link in the calculation of the HashDiff? And that's interesting, because that's what we call a unique HashDiff value. Let me just go to the next slide here. Because here you write that in the book, but yeah, so in the book we use this code here, and we emphasize not to use the hash key when joining the target. So we only join the based on the virtual load end date and the HashDiff value. That's how we join. But then you say, well, a lot of other blocks they emphasize loading loading code where you include the hash key per hash diff, essentially. So, and even if the business key is included in the hash diff calculation, is a specific reason. So here's the thing. What's going on here? The basic design, let's start with that. Basic design is on here, on this page, where you only include the attributes, the descriptive attributes of the satellite in the HashDiff computation. That's it, right? That's what we call a standard, it's a standard HashDiff, it's the HashDiff. In this case, when you load a delta from the staging area into the target satellite, you have to find out for the deltas in the target that belong to the same hash key for the same customer. For this subset of deltas, you want to get the latest delta because that's what you compare against. And you want to compare the hash diff value on the latest delta of all the deltas for the same hash key. This hash diff you want to compare against because that way you know if there's some changes in the staging area which you haven't captured yet. And you have to compare against the latest delta because it might be the case that the first name jumps back and forth, goes from Michael to Mike, back to Michael, all right, and back to Mike, and so on. So, and you want to capture all these changes. That's why you have to compare against the latest delta, essentially. And because there's so many Mikes and Michaels, you have to make sure that you include the hash key to make sure you're identifying the right customer with the same first name. So that's the basic idea. And that works. It's all good. But you have to compare 3 columns. Now, think about this. When we add the business key of the customer, of the parent in general terms, the business key of the parent, either of the link or of the hub, into the HashDiff computation in front of the descriptive attributes, essentially. So we calculate the HashDiff based on the business keys of the parent, concatenated with the attributes, the descriptive attributes from the satellite. That's what we call a unique HashDiff. Now, what happens is you include the business key, and what happens is that the deltas of a particular customer have their own unique HashDiff values. You wouldn't find them for any other customer because these other customers have other customer numbers. And that's why the HashDiff must be, should be different, except on the rare occasion of a hash key collision, right? Or HashDiff collision in this case. So, but we ignore this. So we just don't care. Don't record this better, no, but that's what it is. So you essentially include a business key to make sure that every customer has its own set of HashDiff values in their deltas. Or in other terms, there is no other customer where they share HashDiffs with the customer that you're loading at the moment, or the parent. So that's the basic idea. And with that in mind, if you can guarantee this way that every parent has its own HashDiffs in their deltas, then you don't need to check for the hash key anymore. Because now I can check just for the latest delta, give me all the latest deltas of all your customers, and is the HashDiff from staging among those? Well, this HashDiff only applies to this parent you want to load. So the other ones, the query would ignore because they will be different to the one you're trying to load. And either your current parent has a delta with the HashDiff in the target or not. And if not, load the record. So what happens is that if you include the business key in the computation of the HashDiff, you can omit the hash key. You don't need that anymore. You can directly load with the essentially virtual load end date to compare against the latest deltas and the HashDiff value. That's sufficient. And that way you can reduce the join condition here from 3 columns down to 2 columns. And on traditional databases, when you have to index all this, your index size gets smaller. Because, when you get rid of the hash key, that's 32 characters or 16 bytes at the bare minimum, right? So 20 bytes or 40 characters with SHA-1, for example. So you get rid of the hash key, and that reduces the index size. The join conditions get smaller, and therefore the performance goes up. That's what we call the unique HashDiff. And that's what we do typically. So we prefer the unique HashDiff because it's faster and cheaper index-wise, essentially, and storage-wise and so on. So that's what we go for, the unique HashDiff value. All right, so that's the reason for that. So we prefer the unique HashDiff. And think about this. Yes, you have to include the business key into the HashDiff computation, but who cares? It's computed, it's done, a bit more input, a little bit slower, yes, but it doesn't really matter. And it has all the advantages, right? So that's why we go for it. So we always include the business key into the HashDiff computation, but then you don't need the hash key anymore. Just think about the deltas. All right, cool. Good question. If we have a question like this, and we need more questions, right? So when I say, well, we will not talk about the cluster here, the thing is, I know you guys, you're sending questions on a regular basis. If you would stop sending questions right now, we will talk about this cluster soon, right? But I know you guys now, so you send questions, which is cool. So keep on sending them, and they're really good questions that I have at the moment. Yeah, if you have a question like this or something else, use this form here behind sfr.ee/dvfriday. That's where you can submit your question on a form, essentially. Upload some pictures if you want from your whiteboard if you want. It's all good. We have more webinars. There's 2 more webinars on DBT and RESTscape at scalefree.to/webinars. And we have a forum, the Data Vault Innovators community, that we set up with Ignition Data in Australia. And it's also where we essentially answer questions, where the community asks questions and we answer those. And where we also upload more video material, more webinars, and so on. So it's our essentially community-based approach essentially to support you guys. Cool. So thanks for joining today. I hope you enjoy the rest of the Friday here, and then enjoy your weekend. And hopefully to see you next Friday again. Thank you, guys.